Hello, good day and welcome to Mathematics Online Tutorial. The topic we'll treat today is sequencing and series, and this is Module 2. Here in Module 2, we'll be talking about the exponential sequence, or we can also call it the arithmetic progression. Sorry, exponential sequence or the geometric progression. Okay. Now, in the last module, we talked about the arithmetic sequence. We said if the arithmetic progression, we said that if you are given a set of numbers such that each next term, say for example, we have 2, 4, 6, 8, and so on. Okay, if we're given a set of numbers such that each next term can be gotten by adding or subtracting a constant term, then the sequence of numbers is known as what? A linear sequence or an arithmetic progression. Look at something like this now. 2 plus 2 will give us 4. 4 plus 2 gives us 6. 6 plus 2 gives us 8, and so on and so forth. Okay, so the next term in this sequence is always gotten by just adding 2 to a previous term. Okay, so any term like that we can get either by addition or subtraction of a constant term. Okay, that term is known as an arithmetic progression. But now for a geometric progression, it's quite different. Okay, let's look at the definition from here. A geometric progression, or GP, is a sequence where each new term after the first is obtained by multiplying the preceding term by a constant number called the common ratio. The common ratio is denoted by R. Okay, R can either be positive, negative, or 0. All right. So unlike the arithmetic progression, the geometric progression in this case now, each next term of the sequence is gotten by multiplying a constant number with the preceding term. So if we have a number like a set of numbers or a sequence of numbers like this now, for example, 2, 4, 8, 16, 32, and so on. Okay, this sequence of numbers now follow a geometric progression because each next term can be gotten by what? Multiplying a constant number, which is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Okay. Likewise, if we had something like let me write it in the reverse order: 32, 16, 8, 4, and 2. This is also another geometric progression. Okay, because each next term is gotten by the multiplication of a constant number. The constant number now in this case is what? Half. Okay, you can see 32 times 1 over 2 will give us 16. 16 times 1 over 2 will give us 8. 8 times 1 over 2 gives us 4, and so on and so forth. So any sequence of numbers where each new term is gotten by multiplying a constant number with the preceding term, then that sequence is known as what? A geometric progression or an exponential sequence. Okay, so the next thing we have to look at here is the common ratio R of a geometric progression. Now the common ratio is denoted R. For the arithmetic progression, we had common difference D, but here we are going to be talking about the common ratio R. R is equal to what? T subscript n over T subscript n minus 1. Okay, R is the common ratio, Tn is the last term, and Tn minus 1 is the term preceding the last term in the sequence. Okay, so when we take examples, it becomes clear. Okay, let's look at example number 4. We continue from number 4 because I think we saw that exercise number 3 from the last module. So this is number 4 now. Find the common ratio in each of the following. Find the common ratio in each of the following exponential sequences. Okay, so we want to find the common ratio in each of these exponential sequences. When we look at A, we have 6, we have 12, we have 24, and we have 48. So what is the common ratio in this case? Now the common ratio is quite similar. The way you get the common ratio is quite similar. The technique is quite similar to that of the common difference for an arithmetic progression. We are saying Tn minus Tn minus 1. Okay, let me remove this. So this means a particular term minus the term that precedes it. So if n is 9, we're talking of T9 minus what? Tn minus 1, T8. So this term minus the term that comes before it. So you can get the common ratio either by saying 12 divided by 6, 24 divided by 12, or 48 divided by 24. Not 6 divided by 12, not 12 divided by 24. Okay, or 6 divided by 48, or 48 divided by 6. Two terms that come, the two terms that follow each other consecutively. Those are the ones that you use to divide one, and those are the ones you use to divide each other. And it is in this order: 12 divided by 6, 24 divided by 12, or 48 divided by 24. You can use any of them to obtain your common ratio. Each of them gives us 6. 12 over 6 equals what? 24 over 12 equals what? 48 over 24. Everything is giving us 2. So the common ratio of that sequence is what? Is 2. R equals to 2. Let's look at this B. B, we are given 36, we have 12, we have 4, we have 1 number, 1 over 3. Okay, so in this case now, what is the common ratio? 12 divided by 36, 1 over 3. Okay, so that's that. And then for C, I think you should be able to do that on your own. Negative 8 divided by 4, that will give us negative 2. The common ratio is negative 2. Now let's move to the next subtopic: the nth term of a geometric progression. The nth term of a geometric progression. Now the nth term of a geometric progression is used to obtain any given term in a geometric sequence or in a geometric progression. Tn is given as ar raised to the power of n minus 1. Okay, so this formula can be used to obtain any term in the sequence. You can see, so if, for example, if I'm looking for the second term now, this is what? Ar raised to the power of what? 2n is 2 minus 1, giving me t2 equals what? Ar raised to the power of 1. I don't need to put raised to the power of 1 there. Or if I want to, okay, let me just put it. T3 is equal to what? Ar raised to the power of 3 minus 1, which is equal to what? Ar squared. Can we also see the off by 1 behavior now? Just the way we're having in the arithmetic progression, where the power of the common ratio, in this case now, we're talking of power because we're talking of exponents. Exponents means power, another name for power. I think we've done that in our indices class. Okay, the exponent in this case now of this common ratio is 1 less than the term. When we are doing T3, the exponent power here is 2. When we are doing T2, the exponential power here is 1. When we are doing T1, that's the first term, the exponential power, what will it be? 1 minus 1, giving us what? T1 implies T1 equals to what? Ar raised to the power of 0, which is equal to what? A. Because anything raised to the power of 0 is 1. So we're having like A times 1 here. So you see that in this case now, the power of R is 1 less than the term. Because we have 0 here, we have 1 here. So the off by 1 behavior follows for both the arithmetic and the geometric progression. Okay, let's go now. In the arithmetic progression, this Tn, the definitions are already there. Tn is the last term. There's the last term. This is the last term. This is the first term. A is first term. And then R is the common ratio. And the n is the number of terms that we're interested in. Okay, so I think that's that for that. Now let's move to some solvings. Number 5. Let me clear all this. So number 5. Given the GP 10, 20, 40, 80, okay, giving to find the 8th term, 34th term, and the nth term. Okay, so A, to find A, the 8th term. What's the 8th term? 8th term is T8, and that will be equal to what? From the formula, I will only write this once. In subsequent examples, I won't waste time. Recall Tn is equal to what? Arn minus 1. So T8 will be equal to what? Ar8 minus 1, giving you what? Ar7. I don't think I'll do this again. So the 8th term now, T8 now will be equal to what? Okay, no, not yet. Now we will always, just like the arithmetic progression where you need to get your A and your D. for you to solve anything. Likewise, in this place, we must always get our A and our R before we can get any term in the sequence. Okay, so A is equal to what from the question? A is what? The first term. The first term, that's 10. Then what is R? R is what? Either 20 divided by 10 or 40 divided by 20 or 80 divided by 40. Each of them will give us 2. Okay, so now T8 will be equal to what? A times R. R is 2 raised to the power of what? 7. I should have just put this 10. A is 10 times 2 raised to the power of 7, giving me what? 2 raised to the power of 7. So this will give me 1280. So that's the 8th term. Let's quickly solve for the let's solve for the 34th term. So T34 equal to what? AR raised to the power of 33. That will be equal to what? 10 times 2 raised to the power of 33. The answer is quite large, so I think we should just leave the answer this way. Number 3, what are we to look for? We want to find the nth term. The nth term. So what is the nth term? Tn equals to what? ARn minus 1. Okay. A is given as 10. And R is given as what? 2 raised to the power of what? N minus 1. Okay. This is the nth term. 10 times 2n raised to the power of 1. Now, when you're told to get the nth term of any sequence, the nth term of any sequence will enable you get any term in the sequence very fast. Okay, it enables you to get any term in the sequence very, very fast. The same way we did for the arithmetic progression. See, for example, now, if you are told now to calculate the second term in this sequence, we were given the second term already in the question, but let's just use it to calculate the second term now. We'll be having T2 equals 10 times 2 raised to the power of what? 2 minus 1. 10 times 2 raised to the power of 1, giving you 20, which is what? Which was already our second term. Okay, so when you get the nth term of any sequence, you can just substitute for the value of n to find any term in the sequence. Okay, let's move to the next question. B. Find the first 5 terms of the GP, of which the third term is 4 and the sixth is negative 32. Okay, find the third term, find the first 5 terms of the GP, of which the third term is 4 and the sixth term is negative 32. Okay, so now we are giving the third term T3 equal to what? 4 and T6 equals what? Negative 32. Now we want to find the first 5 terms. That's to find T1, T2, T3, T4, and T5. Okay. T3 equals 4. Wait. T3 implies what? T3 is equal to what? AR squared. And that is equal to 4. And then T6 from the question. This and this. T6 equals what? AR raised to the power of 5, which is equal to what? Negative 32. Okay, so when we solve now, what are we going to be having? When you come across things like this, you have to divide one equation by the other equation so that 2 things can cancel out, just like elimination method. Okay, so I'm going to divide equation 2 by equation 1. Divide equation 2 by 1, so that at least something can cancel out here. Now A can cancel out A here, so I'll be left with only R. Then I can solve for R. Okay, so if I want to divide equation 2 by equation 1, if I want to divide equation 2 by equation 1, what am I going to be having? I will have AR5 divided by AR square equals what? Negative 32 divided by 4. Okay, so this is what I wanted to achieve, to cancel out this A. R raised to the power 5 divided by R raised to the power 2, that's R, this equal to what? Negative 8. So now I want to solve for R. Now when you come across things like this, don't go and say take cube root of both sides and then take cube root of negative 8. This is going to give us a complex number, okay? You don't find root of negative numbers like that because they are complex. This is a complex root. Any negative number under a root is a complex. It's going to give you a complex root and it will result in complex numbers. Okay, something a plus I root b, something like that. And that's not what we're interested in doing. You remember from your logic of indices, we're going to be equating. We'll try and see how we can make this one have a power of 3 so that we can equate the bases to each other. So from indices, I think we've done that already. R raised to the power of 3 equals what? Negative 2 raised to the power of 3. Okay, this is better because negative 2 raised to the power of 3 will still give us negative 8. This will give us positive 4 times negative 2, giving you negative 8. So this is better now. So what do we do? So since the bases are equal, equate the powers. So R is equal to what? Negative 2. R is equal to negative 2. Okay, I think I put something like that there already. D. Consider this geometric sequence. Negative 3, 6, negative 12, and 24. Write down the common ratio. What's the common ratio? R equals what? 6 divided by negative 3, which is equal to what? Negative 2. Find the 15th term. To find T15. And to find any term in any sequence, you should know your A and your R. What is A? A is equal to what? That's the first term here. A is 3, negative 3 rather, negative 3. And R is equal to what? Negative 2. So, and T15 will be equal to what? What's T15? That's AR raised to the power of 14, which is equal to what? Negative 3 times negative 2 raised to the power of what? Raised to the power of 14. Okay? So that gives us what? Negative 3 times 16384, giving you what? Negative 49152. Okay, so that's that about that. Sorry, I noticed I jumped C. Okay, let's look at C now. So this is the answer for D. C. Does the number 48 belong to the geometric sequence 3042? Okay, we want to see if does 48 belong to 3072, 1536, 768. Okay, does it belong to? If it belongs to, it's going to give us a natural number. N is going to give us a natural number. Okay, so we want to see, what we want to check is what term, like if we have Tn equals what? AR raised to the power of n minus 1. So if 48 belongs to this sequence of numbers, okay, if 48 belongs to this sequence of numbers, what term will it be? Which term will it be? Which nth term will be 48 of this particular sequence? Okay, so we're going to be equating 48. First, let's get our A. A is what? 3072. And then D is equal to 1536 divided by that. We're going to be getting a half. D 1536 divided by 3072, giving you 1/2. Okay, so Tn 48. Now we're going to be solving for this. We're going to be solving for n. Which term of this sequence we make this Tn equal to 48? So we have 3072 times 2. What's R? R is 1 over 2, right? Okay, let me put it first. 1 over 2 raised to the power of n minus 1. So what we're saying is, for which term in this sequence is all this going to give us 48? So we're going to be solving for n minus 1. Sorry, we're going to be solving for n. And you recall we've done indices before, so we're going to be doing some manipulations here now. So 48 equals what? 3072 times 2 raised to the power of negative 1. I'm rewriting this one, raised to the power of n minus 1. Okay, so 48 equals what? 3072 times, expand this now, you have 2 raised to the power of negative n times 2 raised to the power of minus 1 times minus 1, positive 1, equal to, okay, I've already put equal to 48 already. Okay, so 48 now is equal to what? Okay, let me divide both sides by, okay, let me divide both sides by 2. Okay, let me take this 2 and this 3072. Okay, there's no problem. Let me do it one step at a time. 48 equals 3072 multiplied by 2. That's going to give us 6144 times 2 raised to the power of negative n. Okay, good. So divide both sides now by 6144. We're going to be having 48 over 6144 equal to what? 2 raised to the power of negative n. When you divide this, you have what? 1, and this will give you 128. So 1 over 128 is equal to what? 2 raised to the power of negative n. Okay, so this, let's rewrite this. We can rewrite this as 128 raised to the power of negative 1 equals what? 2 raised to the power of negative n. Okay, this, or wait, let's write it, let's write it this way first so that don't confuse some people. Let me remove this. Now this 1 over 128, I can also write this as 1 over 2 raised to the power of n, right? And when we were doing indices, I said you can invert both sides. If I invert this side, I can also invert this side. Invert both sides. And to invert means to bring what is under, to bring what is below on top. Okay, so we're going to invert both sides. So we have 128 equals what? 2 raised to the power of n. So can I make this 128 have a base of 2? Yes, that's 2 raised to the power of 7 equals what? 2 raised to the power of n. Okay, so what do I do now? Since the bases are equal, equate the powers. So we have 7 equals to n, or n equals to 7. Therefore, 48 is a term in the sequence. It is the 7th term. You can test that on your own to check whether it is true or not. Okay, so let's go back. What this is trying to say is 48 is the 7th term. That's, if you want to get this 48 Tn, it has to be the 7th term. T7 is equal to 48. That's what it's trying to say. Let's say T7 is equal to 48. In other words, when you put this, all this raised to the power of 7 minus 1, you should be able to get 48. That's what it's trying to say. So 48 is a term. It is actually the 7th term of this sequence. Okay, so that's the explanation. Let's go to E. The second term of a GP exceeds the first term by 4. Second term of a GP exceeds the first term, but that's T2 minus T1 equals to 4. Or I can say T2 is equal to what? T1 plus 4. Let's call this equation 1. Okay, look at the statement again. The second term of a GP exceeds, this second term is more than this first term by 4. It is greater than this one by 4. Or you can write it like this. Second term is greater than this first term by 4. So in other words, T2 would have been equal to T1, but it is not, because for them to be equal, you need to add 4 to T1. So T2, 4 greater than T1. So for them to be equal, you must add 4 to T1 for them to be equal. Or you say T2 minus T1 is equal to 4. Okay. This T2 minus T1 equals to 4 means that when you subtract T1 from T2, you will get 4. Just for example, if I have, though this is not a word problem class, so I won't really explain it like that. Maybe when we get to word problems, I'll explain all these things better. But let me just do a little bit of explanation. Now, we all know that 10 is 4 greater than 6. If you want to express this now, it means that what? 10 minus 6 is equal to 4. It means that when you subtract 6 from 10, you will get 4. So 10 is greater than this 6 by what? By 4. That's what I was writing here. T2 is greater than T1. It exceeds T1 by 4. Okay, so that's that about that. I can't do too much of explanation for the word problems because this is a geometry class and we don't have time. I'm moving with time. Okay, what's the second statement? The third term exceeds the second term. The third term exceeds the second term by 12. Find the fourth term. To find T4. Okay? So we know T1 is equal to A. T2 is AR. T3 is what? AR square. Okay, so from this, let's call this one equation 2. This equation 1, this equation 2. So from equation 1, T2 minus T1. T2 minus T1 implies what? T2 minus T1 implies AR minus A equal to what? Is equal to 4. Okay, and I can factorize A is common to both sides. A open bracket R minus 1 equal to 4. Let's call this one 3. Then from equation 2, what do we have here? T3 minus T2 equals to 12. T3, that's AR cube. AR square minus AR equal to what? 12. Let's factorize also. A and R is common, so we have AR open bracket what? R minus 1 equals to 12. So you see, I'm having R minus 1 here, I'm having R minus 1 here. This equation 4. So let me divide. Sorry about that. Okay. So let's divide equation 4 by equation 3. Equation 4 by equation 3. So we'll be having AR, this equation 4. AR open bracket R minus 1 equals to 12. This divided by this equation 3 here. Let's look at it. A open bracket R minus 1 equals to 4. A R minus 1 equal to 4. Okay? So we're dividing these two by each other. R minus 1 here will cancel R minus 1. A cancels A here. So we have R equals to what? 12 here, 3. So R equals to 3. R equals to 3. And if R equals to 3, we can substitute for R. In equation 1. So we'll be having A open bracket 3 minus 1 equals to 4. This equation 3. That means 2A equals to 4. This implies that what? A equals to 2. So A equals to 2 and R equals to 3. And in the question, we're told to do what? To find the fourth term. To find the fourth term. So T4 now. A plus, sorry, AR raised to the power of what? 3. That will be 2 times 3 raised to the power of 3. 2 times 27, giving you what? 54. Okay, so that's that for that. Let's look at F. F. In a finite geometric sequence, T1 equals to 5. T1 is 5 and T5 is equal to 1 to 8. 1 to 8, 0. Okay. Sorry, this should be 1 instead of 2. Roman figure 1, determine to find T2 and T6. So we want to find the second term and the sixth term. Okay, so we're just going to be doing the same thing over and over and over again. Look for your A, look for your R, put it inside the formula, and that's all. Okay, so now that we're giving T1 and we are giving T5, T1 is the same thing as A. Okay, wait, they use small letter, so let's use small letter. T1 is the same thing as A, and that's equal to 5. Then what of T5? T5, that's AR raised to the power of 4. Substitute for A equals 5 in T5. So what are we going to be having? Well, okay, we're giving T5, this one is 1280. So 5 times R raised to the power of 4 equals 1280. Divide both sides by 5. So you have what? R raised to the power of 4 equals what? 1280 divided by 5. So R raised to the power of 4 equals to what? 256. Then R equals to what? Take, yeah, this one now you can take the fourth root straight away. Take the fourth root of 256. You get what? 4. Or if you like, you say R raised to the power of 4, write this one in index form. This will be giving you 4 raised to the power of 4. Then equate the base since the powers are equal. Okay. This one I can easily take the fourth root because this is a positive number. It's not negative like the other one. Okay, so R equals to 4. Then we were told to do what? We were told to determine T2 and T6. So T2, Roman figure T2, that's AR, giving you what? 5 times 4, 20. T6, that's AR raised to the power 5, that's 5 times 4 raised to the power 5, giving me what? 5120. So that's that about that. Then let's look at Roman figure 2. If the last term of the sequence is 2048, if the last term, how many terms are in the sequence? So we want to find n. Okay, so let's assume the last term, that means Tn 20480 equals to, Tn equals Arn minus 1. Okay, A5 times what is R4 n minus 1. Okay, let's divide both sides by 5 first. Divide by 5. So what do I have? 4096 equals to what? 4 raised to the power of n minus 1. So I'll have to think, can I make this one have a base of 4 so that I can see how I will equate these two together? Yes. That will be 4 raised to the power of 6 equals to what? 4 raised to the power of n minus 1. So since the bases are equal, 4 is equal to 4, equate the power. So we have 6 equals what? N minus 1. This implies that what? N is equal to what? 7. So therefore, 20480 is the 7th term. You can cross check on your own. just check T7 equals, substitute inside the formula and see whether you will get 20480. Okay, I won't do that because of my time. G. To find the two possible values of P, given that P minus 3, 3P plus 5, and 18P minus 5 are three consecutive terms of a geometrical progression. Okay, so if these are three consecutive terms of a geometric progression, we want to get P. We saw something like this when we were doing for the AP. So you will have to find this. We will be able to get P when we solve in terms of the common ratio. I know that this one divided by this one is equal to the common ratio. This 18P also divided by 3P plus 5 will also give me the common ratio, so I can equate the ratios of these two divisions to one another. So I have 3P plus 5 divided by P minus 3. It will give me the same thing as 18P minus 5 divided by 3P plus 5. Okay, so I hope you understand what I'm doing here. This one will give me R. This one will also give me R. If I had a GP now, maybe I had 6, 12, 24, 48. 12 divided by 6 is the same thing as 24 divided by 12. It's also the same thing as 48 divided by 24. Each of them will give me 2. That's why I'm equating these ratios to one another. Okay, let me get rid of this. Let's move on. Now I have this. You can cross multiply. When you cross multiply, you have what? 3P plus 5 into bracket 3P plus 5 equals 18P minus 5 to bracket P minus 3. Okay, so now that we have this, you expand the brackets. When you expand the brackets, we're going to be having 9P squared plus 15P plus 15P plus 25 equals 18P squared minus 54P minus 5P plus 15. Okay, plus 15. Okay, so let's collect like terms together. If you collect like terms properly, we're going to be having something like 18P squared minus, okay, I want this is going to give me a quadratic equation anyway, because you can see square here. Okay, just equating the terms together. Okay, let me just do that here, even though it's going to take my time. 18P squared minus 54P minus 5P plus 15 minus 9P squared. I'm writing this one first. That's 18P squared minus 54P minus 5P plus 15. Then I'm bringing this one to this side of the equation. So I have minus 9P squared minus 15P minus 15P again, then minus 25 equal to 0. Equal to 0. Okay, so I brought everything here, so I have nothing here anymore. So this is equal to 0. Then 18P squared minus 9P squared, that's what? 9P squared minus 18P squared minus 9P squared. So minus 54 minus 54P. Okay, minus 9 minus 54P and all that. That will give us what? Minus 80. This minus 15P minus 15P. This minus 30P minus 35P. And minus 89P. Okay, minus, what do I have left? Minus 25 plus 15, that's minus 10 equals to 0. Then you solve this as a quadratic equation. You'll be getting P equals what? 10, or P equals negative 1 over 9. So those are the two values, possible values of P. We're done with that. Let's move to H. Find the two possible values, if the first, second, and last terms of a GP are 4, first, T1 equals to 4. Second, T2. And what? Last term. Minus 12500, or let's just call it Tn, respectively. Find the number of terms in the GP. So we want to find n. We are given this. So to find n, I think by now we should already be, we should have gotten used to all this already. Okay, so T1 equals to A, and that's equal to 4. T2 equal to what? AR, that's equal to what? Negative 20. So I need to get my R now. Substitute for A equals 4 in T2. So you have what? 4R equals to negative 20. This implies that what? R is equal to what? Negative 5. Okay. So to get n now, to get n, Tn, that's the last term. Recall Tn was given as what? Negative 12,500, negative 12,500. So it means that what? Negative 12500 equals what? A. What is A? A is 4. 4 times, we're using Tn equals AR n minus 1. So this is A. What's our R? Negative 5 raised to the power of what? N minus 1. Okay, so first thing, I divide both sides by 4. And when I divide both sides by 4, I'll be having negative 3125 to be equal to what? Negative 5 raised to the power of n minus 1. Okay, see, when you are solving math, like, you don't just, you see, I divided by 4. I can't just multiply and say 4 times negative 5 and say this is equal to negative 20 raised to the power of n minus 1. It does not follow. I think we've done indices, and if we've done indices, you don't multiply like this because you don't know exactly what this power is. So you can't say 4 times 5 will just give you 20 like that. No. It's only when you are certain. If you have something like this, fine, you can multiply. If you have something like this, these are numbers that you can see with your eyes. But when you are seeing something like n, you don't know what n is, so you can't be so sure. That's why you don't multiply anyhow like this. You have to. So that's why you see I'm still having my negative 5 here raised to the power of n minus 1. And that's what we've been doing since. We've always been very careful when we are solving with anything that has to do with n, or any other variable. Okay, so now I have to think if I can make this have a base of 5. Yes, that will be negative 5 raised to the power of 5. This will give me negative 3125. So I can see now the bases are equal. Negative 5 to negative 5. So what do? I equate the powers. Okay, so I have 5 equals what? N minus 1. So this implies that n is equal to what? 6. So what does it mean? It means therefore there are 6 terms in the GP. Okay, that's that for that. Then let's move on to I. Insert two geometric means between 12 and 3 to 4. To insert 2 GMs between 12 and 3 to 4. Okay, now there's also what is known as arithmetic mean. I didn't teach that in the arithmetic sequence because I just felt we won't really need that. It's just the middle number between two terms in a particular arithmetic progression. So if I have something like 2, 4, 6, if I have something like 2, 4, 6, 8, and they ask me what's the arithmetic mean between 4 and 6, it's just 4 plus 6 divided by 2. So things like that. I didn't really teach that because we will not be using much of it like that. Okay, the same thing here also in geometric means. it's just a middle number between two terms in the geometric progression. So if I had something like maybe 2, 4, 6, sorry, 2, 4, 8, 16, and we are told to get the arithmetic, the geometric mean between 4 and 6. The geometric mean between 4 and 6 is 8. And how do you get that? Just by multiplying this 4, you find the square root of the product between 4 and 16. The square root of the product of what? 4 and 16. 4 times 16, that's square root of 64. It will give us this middle number 8. Okay, so when you're looking for geometric means, you're looking for a number that is in between two terms in a sequence. Okay, so if I want to get the geometric mean now between 2 and 8, that will just be what? The product, square root of the product of 2 and 8, square root of this product, square root of 16, which will give me what? 4. Okay, so that's just geometric mean, but this one is just for a single term. They won't really ask you things like this. If they want to ask anything about geometric means, they will tell you to insert like 2 or 3 or 4 geometric means between something. Okay, and that's what I'm really interested in. Okay, so we just move on with the work, just the way we did for the arithmetic progression. If we want to insert 2 GMs between 12 and 64, okay, so let the sequence be in this form. 12 is the first number. Then we want to insert 2 GMs. Let's call this one X. Let's call this one Y. And then 3, 2, 4. So we want to insert 2 numbers between 12 and 3, 2, 4, which we call X and Y. X now is like our T2, and Y is what? The third term. So this is the first term, second term, third term, and 3, 2, 4 is the fourth term. Okay, so A equals what? 12. T1, A, 12, and T4, that's AR cube equals what? 3, 2, 4. Let's get R. What is R? What is R? So substitute in T4. So we're going to be having A, 12 times R cube equals what? 3, 2, 4. So divide both sides by what? By 12. So I have R cube equals to what? 3, 2, 4 divided by 12, and that's going to give me 27. So R cube equals to what? R cube is equal to 27. You try and think, can you make this thing have a power of 3? Yes, that's 3 raised to the power of 3. So what do you do? Since the powers are equal, what do you do? Equate the base. Equate base. R equals to 3. So R is 3. A is what from the question? A is 12 and R is 3. So what is X? X equals what? T2, that's AR, which is equal to what? 12 times 3, 36. And then Y, that's T3, AR squared, which is equal to what? 12 times 3 squared, which is equal to what? 108. So the sequence, therefore, the sequence will be in the form. The sequence will be 12, 36, 108, 3, 2, 4. Okay, you can see it even follows a very good geometric progression. You can see 12 times 3 is 3, 36, 36 times 3 is 108, 108 times 3 is 3, 2, 4. So these are the 2 geometric means between 12 and 3, 2, 4. Number J. Okay, the population of a town increases at the rate. Okay, for this one you have to pay very good attention. Please pay very good attention. If not, you might not get it very well. I will only explain this very well in this example. The K, L, and M, they follow a similar pattern. So this particular question in J, and I'm only going to be doing the proper explanation in this particular J. For K, L, and M, I'll just use the terms I derive to solve through. So if you don't get it now here, you will not understand what I'm doing in the other examples. All right, let's look at this question. The population of a town increases at the rate of 10% annually. Okay, so it has 10% annually increase. Its present population is 200,000. Present population 200,000. So what did it ask? What will be its population at the end of 5 years? What will be its population? To find Tn in 5 years time. So we want to know what will be the population in 5 years time. So you can see that we can use all this arithmetic progression and even geometric progression to progress or predict future events. Okay, we just put them into some mathematical models. We model them very well, and from the model we can predict for things that will happen. So if this country's population, or this particular, what they call it now, but this particular town, if its population is increasing 10% annually, now let's get to solving. Now the present population, I'm going to solve this normally. I'm not solving it as if I'm using any geometric formula or anything. No, I'm just solving it normally first. Then when I solve normally, I will now use the geometric way to compare so that we understand perfectly. Present population, that is A first term, first population, like present, what you are working with presently is your A. So A is equal to what? 200,000. Now what is the increase of population at end of first year? That will be equal to what? 10 over 100 times 200,000. You know, the population is increasing at 10% annually, 10% of the current population. So the increase at the end of that year, on the end of the first year, is 10% of 20,000, which is 20,000. So that means the increase in the number of the population will be 20,000. So 20,000 people, 20,000 more people would have been born, or I don't know how they calculate their own annual increase. Maybe plus immigration, plus birth rate and other things, it will increase by 10%. I don't know. Okay, but the total number of new people that will be added to the town is 20,000, which is what? 10% of 200,000. That's at the end of the day. So now, what is the increase? So what is the total population at the end of first year now? So total population at end of first year, that will be equal to what? Increase in population plus population at start of year. Okay, so the increase in the population, which is 20,000, plus the population at the starting of the year, which is 200,000, which is equal to what? 220,000. So this is going to be the total population at the end of the first year. They started with 200,000. At the end of the year, it would have increased by 10%, which is 20,000. So the total number of people now in that town will be 220,000. I think this is clear enough. Let's work for the second year. For the second year. Now, what is the population? What is the population at the beginning of the second year? Beginning population at start of year 2. So what is the population at the start of year 2? The population will be what? 220,000. You know what they ended with last year, maybe December 31 was 220,000. Then January 1st of the next year, it will be 220,000. And you know, this population is increasing 10% of the population of the current year. They did not say 10% of, only the first year. They said it is increasing 10% of the population every single year. So if it is 300,000 this year, to increase 10% of 300,000, that's 330,000 at the end of the year. If it is 500,000, to increase by another 10% at the end of the. Okay, so if it's 500,000 increase, sorry, if it's 500,000 at the start of the year, what will be the increase at the end of the year? 10% of 500,000, that's 50,000. So the total population at the end of the year, what? 550,000. So like that, like that. So for the second year now, the population at the start is 220,000, because that is where we stopped from the previous year. So what is going to be the increase at the end of second year? So increase at end of second year. That what? 10% of 220,000, which is what? 22000. So that's 22,000. So the increase is what? 22,000. So now what will be the total population at end of second year? There will be increase in population plus population at start of year, at the starting of the year or at the beginning of the year. That will be equal to what? What's the increase? 22,000 plus 220,000, giving us what? 242,000. So you can go on and on like this till you get to the end of the fifth year, but that's just if you are solving normally, and it will defeat the counsel of the geometric progression. When you can model things like this in a geometric way, why waste your time going through a lot of stress? So let's model it using the geometric progression. Now let's look at this. Let's look at now using GP to model it, to model this. So we're going to be having the present population A 200,000 at the beginning of the year. Let me make it clear. Okay, so present population at start of first year. Present population. That's our A 200,000 because it's the first term. This is the first term. A is 200,000. Good. Increase at the end of first year. What's the increase at the end of first year? That's what? 10 over 100 times 200,000. This 10 over 100 is the same thing as what? If you divide it to give you 0.1. This 200,000 is the same thing as what? A. So I can say the increase at the end of the first year. This implies what? Okay, wait. This is equal to what? 0.1 times A, or A open bracket 0.1. It's the same thing. This one times this one. Okay, so increase at end of first year equals to what? A open bracket 0.1. That's 200,000 multiplied by 0.1. If you put that in the calculator, you will get 20,000. Okay, so what's the total population at the end of first year? So total population at end of year one is equal to what? Increase in population plus population at plus population at start of year. So what's the increase in the population? Is this 20,000? A open bracket 0.1 plus what? What's the population at the start of the year? That's 200,000, which we represented as A. I can factorize here. A is common to both sides. So I have A open bracket what? 0.1 plus 1. Okay, just factorize. And if I decide to open this bracket, I have what? A open bracket 1 plus 0.1, 1.1. So this is the total population at the end of the first year. Total population at end of first year. So total population at the end of first year is equal to A open bracket 1.1. You can test it out. You know A is 200,000. So multiply 200,000 times 1.1. You should be getting 220,000. Okay? So I think just follow our modeling it. So you get 220,000 when you do that. Okay? So I hope we're following this carefully. Now let's solve for the second year. For year 2, let's solve for the second year. For year 2, now we need to know what we are starting with. At the beginning of the year, at the beginning of the year, okay, population at start of second year. What's the population? That's going to be 220,000. Okay, 220,000. You can substitute, if you substitute here in this place, 8 times 1.1, 200,000 times 1.1, it will give us what? 220,000, same as what we got at the end of the first year when we're solving normally. Okay, so population at the start of second year is 220,000. Okay, I would have just represented this with a variable like A open bracket 1.1, but I want you guys to understand. That's why I'm writing the 200,000 in clear terms like this. Now, what is the increase? Increase at the end of year 2. So increase at the end of the second year, that's 10 over 100 times 220,000. Okay, which is the same as this is what 0.1 times 220,000. Okay, then what is going to be the total population at the end of year 2? Total population at end of year 2, that will be equal to what? Increase in population plus population at start of year, at the start of the year, which will be what? 0.1 times, this is the increase, 220,000 increase plus population at the start of the year, that's 220,000. You can also see that this 220,000 is common to both sides, so I can factorize 220,000 open bracket 0.1 plus 1. That's this 220,000. I factorize it out, okay, and this can still give me 220,000 open bracket. If I add these two together, I have 1.1. Okay, So this is going to be the increase at the end of the second year. Okay, so and if you recall, this 220,000, what was it from the we have something that we used to represent it. It was A open bracket 1.1 total population at the end of the first year. Total population was A open bracket 1.1, which gave us 220,000. So if I want to substitute this 220,000 now, I can write it as what? A open bracket 1.1, because it's the same. If you substitute 200,000 from the previous question times 1.1, you get 220,000. So this can be written as A open bracket 1.1 times what? 1.1, giving me what? A open bracket 1.1 all square. So this is the total population at end of year 2. Okay, so you can check it out. 200,000 open bracket or times 1.1 all square, you will get the same 242,000 that we are getting at the end of the second year when we solve normally. Okay, I'm just doing all these explanations so that you understand this concept very well. Next questions, I won't do all this, I'll just go straight to the point. Okay, so if you drive at the end of the third year, if you work following this particular concept, at the end of third year, the increase in population will be A open bracket 1.1 cube, end of fourth year, and so on and so forth. So now we want to know we want to find the, where's the question? The population at the end of 5 years. At the end of 5 years, so it means that we're going to be looking for T6, the sixth term. Why am I using sixth term instead of the fifth term? Because the sixth term is AR6 minus 1, giving me AR raised to the power of 5. Okay, so for the first year, I was doing like you get what I'm trying to say now? Because if I used T5, it would be AR raised to the power of 4. I'm going to be looking for fourth year, but now I'm looking for the fifth year. That's why I'm using T6 instead of T5. So the fifth year now, so T5 equal to what? T6 AR raised to the power of 5. And what is our A? A is 20,000. R is what? This is the R, 1.1. So substitute. So T5 now equals what? 20,000. Sorry, not 20,000. It's 200,000. 200,000 multiplied by what? 1.1 raised to the power of what? 5. Okay, so this should give me 322,102. So this is it. So this is going to be the estimated population at the end of 5 years, 322,102 people. Okay, if you solve this normally too, without using the GP progression, you still get the same thing. All right, let's move to K. So solving for KL and M will not be difficult now because we already know how to model this thing already. The value of an automobile depreciates at the rate of 15% per year. Okay, so depreciation rate (15%). Okay, when something is depreciating, it means the value is going down. It is not increasing, it is decreasing. What will be the value of an automobile in 3 years' time, which is now purchased for 45,000 naira? Okay, so the current price is what? 45,000 naira, and it's depreciating. Okay, depreciating at the rate of 50% per year. Okay, so at the start of first year, that's A is what? 45,000. What's depreciation at the end of the year? Depreciation at end of year, that will be what? 15% of 45,000. Okay, now we're going to be using the previous logic. This 15% is what? 0.15. This 45k is our A, so 0. Times A. So the increase at end of first year is what? A open bracket 0.15. Now what's the total population? Total population at end of first year, that will be equal to what? This decrease, sorry, is not, I'm still saying population. How am I saying population? Decrease, the decrease is in the price of the automobile. So the decrease at the end of the first year is A open bracket 0.15. If you put this inside your calculator, that's 15% of 45,000, 0.15. This A is 15% is 0.15, and A is 45,000. If you do that, you are going to be getting you'll be getting 6,750. So that 6,750, you are going to be subtracting it from the original price because it is depreciating. So you can't add it to the original price. So if it was maybe, for example, let me use another example. Maybe I bought a laptop for 100,000 naira and it is depreciating by 10% every year. Okay, so if at the start of this year it is 100,000 naira, if at the end of the year it has depreciated by 10%, that means 10,000 naira has gone. So what will be the new cost for the laptop now? If I want to sell it, it will be what? 100,000 minus 10,000. It has depreciated by 10%, which is 10,000 of 100. So that would be 90,000. I will sell it. At the end of the second year, if it depreciates by another 10% of 90,000, that's 9,000 naira will go from 90,000. So if I want to sell it at the end of the second year, that's what? 90,000 minus 9,000, giving me what? 81,000. Do you understand? So it's depreciating by this and that. So now if one now want to get the total cost now at the end of the first year, okay, that will be the original amount, 45,000 naira, minus this is the money at the start of the year, 45,000 minus what? 0.15 times 45,000 is 15% of this. So 45,000 is our A minus what? This depreciation, which is what? A times what? Or let me follow this pattern, 0.15 times A. Okay, I can factorize A here also. So I have A open bracket what? 1 minus 0.15. Okay, and this will give me what? A open bracket what? 0.85. Okay, so I hope you get how I factorize this. A times 1 will give me A here. Then A times minus 0.15 is what? Minus 0.15A. Okay, so that's just how I factorized it. Then 1 minus 0.15, I can perform arithmetic with this to just the way I did the other time. So I have A open bracket 0.85. Okay, so we won't solve for the remaining 2 years. We're just going to be using the same logic that we used before. It means at the end of the second year, if the total cost, or let me say new cost at end of year 1 is equal to what? A open bracket 0.85. If you even check this out, you'll be getting exactly what you're supposed to get. That will be 45,000 times 0.85. 45,000 45,000 times 0.85, giving you 38,250. But this is just aside. This is supposed to be the money you get. If you remove 15% from 45,000 at the end of the year, you will get 38,250. Okay. So we're going to be using the logic from the previous example. The new cost at the end of the second year will be what? New cost at end of second year. That will be what? A open bracket, what is 0.85 square. At the end of the third year, A open bracket 0.85 cube. Okay, so we're going to be doing that. So, but we won't be doing all that anyway. So, A, what does it imply? It implies that what? A is what? 45,000. That's the initial money at the start. Then what is the ratio? 0.85. This is 0.85 is going to be the common ratio. So we're doing for the third term to solve for the amount at the end of the third year. So we're going to be using T4 so that we will have something like this AR cube third year. If I used AR3, I'll be having AR square, so I'm using T4 to give me AR cube. Okay, so AR cube now equals what? 45,000 times 0.85 raised to the power of 3, giving me what? 27,635.625. Okay, so that's going to be the cost at the end of 3 years. The money would have depreciated from 45,000 naira to 27,635 naira at the end of 3 years. Okay, so that's the final answer. Let's look at this other one. L. Statistics Canada estimates the population growth of Canadian cities, provinces, and territories. The population of Nunavut is expected to grow annually by 0.8%. So this is massive growth. 0.8%. That's 80% increase every year. Wow. I wonder how that will happen anyway. Okay, maybe because of the immigration in Canada, I can't say, but that's very, very massive. 0.8%, that's 80%. 80%. Okay, so the population is expected to grow annually in Nunavut by 80% or 0.8%. So every year the population will increase by 80%. You know, 80% is 0.8. Okay. Now, in 2009, its population was about 30,000. Okay. Annual growth 0.8% of present population. Okay, so in 2009, its population was about 30,000. Population 30,000. Okay, this is the start. At the start of 2009, population was equal to 30,000. Estimate the population in each year. Correct to the nearest thousand. Okay, we want to estimate the population in 2013 and 2049 to the nearest thousand. Okay, so Roman figure 1 now in 2013. Now 2013 is how many years after 2009? That's is it 2013? That's we're working for the 5 years because 2009 is going to be a part. We are doing 2009, 2010, 2011, 2012, and 2013. Okay, so we're working for 5 years. 09. We only know the population at the beginning of the year 2009. We don't know the population at the end of the year. We work for 2010, 2011, 2012, and 2013. Okay. Now, you know from the previous work that we have been doing, 80 over 100 times population increase at end of 2009, end of the first year, that's 2009. That's 80 over 100, 80% of what? Of 30,000, which is what? 0.8 times A. A is 30,000 because it is the first term that was given, first term. Okay, so A into this. Then the total population at end of 2009. About increase in population plus population at the start of the year. That will be equal to what? 0.8 times A. This is the increase plus the population at the start of the year. A open bracket was 0.8 plus 1, giving you what? A open bracket 1.8. Okay? So now, to find population at the end of 2013, though it was not specified here whether at the end or at the beginning of 2013, but let's just work for the end of 2013. Let's assume that's what they are looking for. Okay, and that's what we're looking for, the population in the next how many years? In the next 5 years. Okay, so we're going to be using T6 equals AR5. What is A? A is what? 30,000, and R is what? 1.8 from previous knowledge. Okay, so we're going to be having 30,000 times 1.8 raised to the power of 5, giving us what? 314,928. Okay. Okay, sorry. I think now when we're given a population of this Nunavut to be 30,000 in 2009, I think it's safe to assume that they were giving us the population at the end of 2009. Maybe after the whole census and everything, when they had calculated, oh, it's 30,000. So let's assume that this is the end of 2009. So we were starting from the beginning of 2010. The beginning of 2010. So we won't solve for this since the population was given to us here. The question was not very clear enough anyway, but let's just use simple logic to solve that. Okay, so we're going to be solving for 4 years. 2013 minus 2009. How many years are in between? 4 years. Okay, so we're solving 2010, 2011, 2012, and 2013 because I think it's safe to assume that way. Why? Because when we're also giving our own data, the estimate of the population in 2013, it's going to be for the end of 2013. We're going to be solving for the end of this year. So let's assume that they also gave us their own population at the end of 2009. Okay, so this should be at the end of 2010. So we started from 2010. So instead of doing T6 now, we're going to be instead of T6 now, because we're looking for 4 terms, it's going to be T5. Okay, so AR raised to the power of 4. So this raised to the power of 4. Then when I do that, I'm going to be having what? Okay, it's the same. Okay, I already did this already. 314,928. Okay, so to the nearest thousand, what's this to the nearest thousand? That was 315,000. So 315,000 is going to be the population in 2013. In 2013. Okay, let's solve for B in year 2049. So 2049 minus 2009. So we're projecting for the next 40 years. What's going to be the population in the next 40 years? That's T41, AR40. Okay, 30,000. You know your A is 30,000. Then what is our R? 1.8 raised to the power of what? Raised to the power of 40. This will give us an extreme value 4875525 dot 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 dot. Okay, so you can just leave your answer like this, and that's that for that. M, final question for me. Between the Canadian censuses in 2001 and 2006, okay? So there was a census carried out in Canada between 2001 and 2006. The number of people who could converse in Cree had increased by 7%. Okay, so the number of people that could communicate in a particular language known as Cree increased by 7%. Okay, in 2006, so probably at the end of this year, 2006, 87,285 people could converse in Cree. Assume the 5-year increase continues to be 7%. Estimate to the nearest 100 how many people will be able to converse in Cree in 2031. Okay, so between a 5-year interval, 2001 and 2006, it was noticed that the number of people who could converse in Cree increased by 7% in 2006. Okay, so in 5 years, 7% increase in people who can speak Cree language. Okay, in the year 2006, we had 87,285 people who could converse in this Cree. Okay, so our A is going to be 87285 because this is what we're going to be working with. Since we want to calculate we want to see how many people will be able to converse in Cree in the year 2031. So we're going to be working from that 2006, end of 2006 to the year 2031. Okay, so, and you know the common ratio is given as what? The common ratio is given as, okay, I can't call it the common ratio yet. Let's just solve first. Now, if A is 87,285, now, increase at the end of the next 5 years. That will be equal to what? You know, it's increasing by 7% every 5 years. 7% of the previous population. So this is the current population now. Current population. And this should be at the start of 2007. In the ending of 2006, 87,385 people could converse. So at the start of 2007, you get? At the start of 2007, we are going to be having this. So we are going to be doing 2007 to 2011. That's another 5 years. 07, we are going to be doing 2007, 08, 09, 10, and 11. 1, 2, 3, 4, 5. So these 5 years. Because what was given to us was the end of 2006. Okay. Okay. So that's that about that. So increase at the end of the next 5 years, 7% of what? Of 87,285. So that's what? 0.07 times. This is giving us our A. This is the increase at the end of the next 5 years. So what's going to be the total population? Total population at end of next 5 years is equal to what? Increase in population plus population at the start of the year. That will be equal to what? What's the increase? The increase is what? 0.07 times A plus what? Population at the increase of the year, which is A open bracket, if you factorize 1 plus 0.07, which is equal to what? A open bracket, what? 1.07. Okay, so therefore A is what? A is 87,285, and our R is what? 1.07. So over the period of how many years are we working? From 20, we are doing it from, well, we want to project from the end of that 2006 to 2031. That's some 25 years. Okay, 25 years. And if it is going over a 5-year interval, divide by 5. So that means we want to project for 5 terms. The first term we end from 07 to 011 to 2011. That's the first term. The second term we start from this 2012 to 16, and so on and so forth. So we have 5 terms before we now get to what? 2031. I think you understand what I'm trying to say. Good. Since we are doing it over a 5-year period. Okay. So the estimated population now of people that can speak Cree in 2031 will be what? A open bracket 1.07 raised to the power of 5, which is equal to what? 87285 times what? 1.07 raised to the power of 5, giving me what? 122,421.7278. Okay, we're told to estimate to the nearest 100 how many people we will to converse in Cree in 2031 to the nearest 100. Okay, nearest 100, which will be equal to what? 122,400 to the nearest 100. Okay, so that's that about that, and that brings us to the end of this tutorial for module 2, the tutorial sequences and series, module 2. Here we talked about the exponential sequence, and we've seen how we can solve different questions on exponential sequence, how we can project for things in time to come, and so on and so forth. Okay, so after this we're going to be moving to the next module of this chapter, which will conclude the sequence and series chapter for us, and that will be talking about series. Okay, so just watch out then, and by the end of that tutorial we must have concluded everything that has to do with sequences and series. Please make sure you practice very, very well. Thank you.